Hello and welcome to day 2 of Industry Week 2021. And welcome to the final talk of the day, guys. We have an absolute technical treat lined up for you tech heads, animators, modelers, and engineers. Hashtag IW21, you've heard it before, have the post with the most, remember. If you have any questions during the talk, guys, use the Q&A function, ask a couple of questions and we'll get to it at the end. So guys, since the early days of higher education at Confetti and higher education games at Confetti, our next guest has been supporting us with the absolute top tier advice, technical expertise and friendship. Throughout his impressive career, he has worked for the biggest names in the industry, and including Rockstar Games, King, Splash Damage, and Facebook. It is my absolute pleasure to introduce freelance VR technologist and my friend, Andy Davis. You're on mute.
And I'm in the room.
There he is. Yes, he is here. He's here.
Yeah, good morning, everyone. I am in California right now, so it is morning for me, and I'm sure you're like all quite tired and zoomed out. So I've got good news and bad news. So the bad news is I'm going to be talking at you for 2 hours with technical art stuff. The good news is that I'm going to try and go through a lot of the heavier stuff in the first speech, the first talk. So if you're still awake by after an hour, we can get into a little bit more of the fun stuff. So I hope that's a good deal with you. Great. Okay. So this is the first talk I'm going to give. The first talk's on technical animation, and the second talk is going to be on virtual reality development. So I will explain a little bit who I am, and if you're not sort of familiar, and thanks for that big fanfare as well, Jin. That was great. So ego boosting.
Anytime, man.
So I did my master's degree in 1998 at Teesside University, and then I went on to work in the multimedia industry. And after a few years, 2 or 3 years, I ended up getting to the games industry where we were working on PlayStation 2 games, Magenta Software. And after a while, I jumped ship and found myself at a startup just outside of Manchester. And that startup became TT Fusion, which got wrapped into Traveller's Tales, Warner Brothers. And that was quite exciting. And I became, after a few years, I became a senior environment artist. And what happened was that I found I was using a lot of the techniques of the computer science ideas and the pipeline ideas that I got from my master's degree, and spending a lot of time doing that rather than being a full-on traditional artist. So I realized that I was some kind of a technical artist, but that phrase didn't really exist back then. But what I found was that it was a phrase that did exist for Rockstar Games. So I started working at Rockstar Games as a technical artist. And I worked there for 6 years. And since then, I've worked at a few other companies, as Jin told you about. And the first of those was I worked at King for a while, working on mobile games. Then I worked at Splash Damage. We worked on the first-person shooters, like a Dirty Bomb, and then I got the chance to work at Facebook. So I'm currently out here in California at the moment, working as an independent virtual reality developer and creative technologist. and sort of I've got some like sort of big projects too. I'm on a big virtual reality project at the moment, and I've got some exciting augmented reality things coming up soon. So so let's start talking about technical animation. So technical animation is it's quite an interesting area, speciality of technical art. And so what I'm going to go into is where the animation side of technical animation leads to a few special disciplines, specific disciplines. So we're going to talk more about animation roles, but we're not going to talk about being an animator, because that's not what technical animation is directly. So so here's a variety of roles, and I'm going to go through them now. So a character animator is that's the character that we as technical animators can support. But it's not something I've ever done. But the idea is that the animator is, for anyone getting into animation, this is the key role. I'm sure you've had a great introduction to animation on your own course. And so the tools that we're working with the 3D platforms.
Andy,
so
are you showing your presentation right now?
I am.
I just want to share that on the screen.
I might not be sharing that.
Thanks, man.
Right.
We've got your Unity up.
There we go. And
beautiful.
So technical animation, the roles. So yeah. So here we. So as a character animator, you're going to be using 3D platforms. And you've been extensively using 3D Studio Max, as I understand, and I've used Max. I've extensively used Maya as well. Blender is coming onto the market like in quite a big way, and even though a lot of the games companies don't use Blender so much, it's being adopted by some of the tech companies, and I think more and more, but simply because it's a free platform, that more and more it's going to become accepted into the industry. There's a lot of tools that are already getting integrated with the Blender pipeline, like in augmented reality. Facebook recently released the Blender Spark AR toolkit, for example. So it's going to sort of come into the industry a little bit more. And so the next one I'm going to talk about is the technical animator. So as a technical animator, this is more of an all-rounder character who you're going to be concerned with not just characters as such, but you might be involved in animating vehicles or dealing with simulation animations as well. So that's why a couple of these other kind of tools start to come in. So like Motion Builder, and having to handle motion capture data is a huge area to go into as a technical animator. And it's going to be much more engine based as well. So you're looking at needing to get some time with like Unreal or Unity, and also you need to be able to get to grips with the associated scripting or coding language. So with Unreal, that would be C++. Or you can use blueprints, but to really get your hands dirty, and as soon as you need to get any of the nuances, you have to really sort of get into C++. With Unity, it's some C#. So that makes things a little bit more straightforward. And Motion Builder, that can be controlled with Python, although you can get lower level and make C# C++ extensions with that. And so technical rigor is really only concerned with specifically handling setting up the character. So it's a virtual puppet creator essentially, and you're setting up the virtual marionette. So yep, you're still going to be using some of these tools, but it's cut back from a general technical animator role. So the character 2D is it's sort of halfway between a character animator and a technical animator. And this is a role that's come up quite a lot in the VFX industry and the movie industry, the TD industry. So again, it's going to be using Motion Builder, and very often that a lot of films, they're starting to incorporate Unreal Engine into their pipelines. So that's become quite exciting. So that they can create pre-visualization renders. And certainly there's a lot of the big companies like Lucasfilm and certainly like Marvel movies are creating like sort of real-time visual effects, like mock-ups while they're filming, so they can get an idea of what they're doing as well. So not only for pre-visualization, but also kind of like sort of actually production filming. So, but the character 2D role is sort of another thing that can be done. Yeah, specializing in VFX is another technical animation discipline, and so that's primarily all based. It's a role based on simulating natural phenomena such as explosions, lighting, dealing with particle effects, and weather systems. So some of the tools are a little bit different. Like Houdini is the big one for the VFX artists. Houdini is sort of the industry standard simulation software, and it has been for a long time. Simulation can be done to a certain extent on Maya, but Houdini is still the master, and even Unity's got a new Houdini workflow system within it. And also Nuke. Nuke is used for the compositing side of things. So as a VFX artist, you're going to be working with Maya elements, Houdini elements, and you're going to be compositing them and coming up with like shaders, shader development within Nuke. And finally, there's a role that's related to that side of things, and you've got a motion designer. And motion designers, as a 3D platform, quite a few of them do use Cinema 4D. So that's something of a curveball, because I found it was not something I'd use particularly, but it's very popular in the motion design community. And also, as well as Nuke, motion designers are quite fond of After Effects. So let's talk a little bit more about the second role on that list, and that's technical animation. That's mostly what we're going to continue talking about. So in technical animation, the basic thing that you're going to be dealing with is looking at how to organize characters. And this it's not always a character specifically, as in like a human or an animal, a creature. It could be a vehicle, and a lot of these ideas work across, they translate across. So we have this the root node, and this is how I like to organize a character rig. So we base from a root node, and the main group of meshes is stored in a model group, and within under the root node as well, we have a skeleton rig group. So that's the joints for the characters and possibly the rig objects such as constraints. The rig group is a group of controls that we've created for the skeleton, which map to the joints, and possibly we could have blend shapes as well. And those blend shape nodes connect to the model group. And then finally, I think it's really useful to have a data node as well, because we can add our own custom information about our rig within the character rig. and that can give us something that we can query and give us information specific to the character that we can use in the game engine. And the idea is, when we've got a root node like this, we can have the character as one element that we can export as a single asset. And if we have a rigid hierarchy like this, we always know what we're dealing with if we're coming to using assets within a game that we're working on. So that's what it's all about. It's about homogenizing the whole process so that we can expect certain results when we're sort of dealing with our assets as a technical animator. So so now let's have a look at how this can work out in Maya. And what I've got here is a model. It's my crazy flower model. So I'm going to stop the presentation, and we're going to go into Maya and see how that works. Right. So here's my my model, like weird crazy flower, and the idea is this. It's like inspired from like a 1960s BBC TV children's cartoon, and that's the idea. So it's a really basic model, but the important stuff is over here. And here we on the left hand side, we can sort of see how this hierarchy plays out. So here we've got our root node, and we've got the rig and the joints here. And this is like the mesh. So this is how this sort of this hierarchy like plays out. If I wanted to export this into a game engine, it'll be nice and straightforward because there's only one node to select, and this would give us the power that we needed if we and the simplicity, so that we could take our model into Unity, Unreal, get it working. So we're going to look a little bit further about how this works, but so I've got a set of animated keyframes that excuse me, and we can see I've got like sort of two basic animations worked out. So that's essentially the formation of the rig. So the advantage of having the entire character contained under one node is that it allows us to save it as an exclusive asset. And I did find that one of the key gotchas I discovered in Maya was that in grouping a model and its associated rig can cause transformation problems. So what we've got to do, we've got to take the top group node, and if I get into the attributes, we've got to make sure that the top group node, let's have a look. Here we go. We have to turn off inherits transform, and when our model is rigged up, otherwise our model gets double transformed by the rig node as well as by the bones. So that's quite important. So it's like so there's always like a couple of gotchas, and there's a couple of like things that we have to like sort of work out or find when it comes to rigging. So and that's like sort of like one of these things we've got to work out. Right, let's get back to our presentation. And we're going to now get into what I actually have to physically do as a technical animator if I have an animation project. So I hope this doesn't scare you too much, but it's you're putting a lot of good work today on like checking out these Zoom lectures, and this is the so-called thinky bit. So this might be the highlight, or this might be the bit that sends you to sleep, but this will just give you an insight into how technical animators think and the sort of problems that we've got to encounter. So we're going to take a deep dive into PyMel, and PyMel is a set of Python libraries that use Mel, which is Maya's embodied language, and it's a really nice Pythonic way of being able to write Mel code, and like scripting gives us so much power when we're going to deal with anything, and particularly in animation. So when I normally come to Confetti, I give a workshop and actually have you all coding, but we can't actually do that, unfortunately. So instead, I'm going to be coding right now in front of you. And so this is, let's go through a script and just give an animation of the kind of work that you would have to do as a technical animator. So there are a variety of queries that we need to make with a rig in order to perform animation related tasks. I tend to code using PyMel, and I sort of find it's really nice that we can get to handle objects rather than have to deal with strings, because there's another library called the commands library it's another Python library, and that has you dealing with strings. But as I say, PyMel's like really Pythonic. So using that strategy, it becomes really simple to query a rig for information. So we're going to have a look at writing a script which helps us query our rig, and this is like a really sort of basic idea. So so the first thing we do when we start a script, this is right at the head of the script, and we've got to tell our Python script that we are going to use certain libraries. Now, the libraries are collections of functions. So the opening line is where we're telling the program, we're telling the engine within Maya to use specific sets of functions. So we've got import pymel.core as PM. So that we're telling Maya that the pymel.core library is going to be used, and we're giving an abbreviation by calling it PM. Just it's like a shorthand. Then the second line, we've got import pymel.core.node types as NT, and the node types represent all the different types of elements in a scene. So they could be meshes, they could be lights, they could be joints. So we're making a shorthand to whenever we're going to talk about any kind of element or asset, it's going to conform to a node type. So so the next stage is this is where we start to actually get into the body of the code. So this like Python is all about it's an object-oriented programming language, and object orientation gives us the chance to not just give a computer a list of commands to follow, but what it does, it creates entities, and these entities, we give them properties and we give them behaviors. So we have to create what's called a class, and in that class we create properties and we create methods, and those methods tell us what to do with the information that's being held in an instance of our class. So the way we define a class, we have this keyword at the start, class, and we're going to create this class character rig. And the first line that in Python that we use to create our class is this init line. It looks pretty ugly, but that init is a standard function. And as soon as you get into programming Python and using classes, you'll be hammering it out really quickly. It's used constantly. So within that, that def line, we've got the init, the 2 underscores at the start and the end, and the next word is self. And what that means is we're giving the function a reference to itself, so that it understands. It's like a point of reference to so that we always know what we're talking about. So in our case, we're adding as a second argument. So and the brackets after the init involve what we call arguments, and that's specific information that we're sending to our function. And we're going to send it a root object. If we're going to like relate that to Maya, what that would be the root object would be an object in our actual Maya scene. So it would be the head of our character rig. So we created our character rig before with the crazy flower, and it would be the very top node would be the root. So when we define our character rig script, we've got this keyword set up for our root, and the next line, the third line here, is this is the only information or a piece of code that we're going to put into our method. And what we're going to do is we're defining this root. It says self.root is assigned root. So what that means is that the instance of the character rig is given a new property called root, and we are going to send that the root that we passed it in the init line. So what this is, essentially this is the most simple form of a class that we could have. And once we've got a property and we've got a method, and as soon as we've got that set up, we can start to add more methods. So that's going to be the next stage. So this is a property that we're going to add to our class. And in Python, you define properties using this @property keyword, because what it is, it's kind of interesting, but in Python, methods are used to handle data inside an instance of a class, but properties are a special kind of method, and that's how it's done in Python, which is kind of unusual because in C# it's sort of a little bit different, but this is how we define one anyway. It's similar to the def init line. So we use that signifier, the @property, and def is it's a definition. It means it's a function. It's a type of function, and we're going to create this property called joints. And what this is, it's the idea of if we've got our character rig selected, if we ask our character rig where the joints are, what joints are within our character rig, this property will find all the joints within our character rig. So that's the idea. Now the second line is like really next level stuff, and this is where Python gets sort of quite complicated. This is probably not the simplest way to do what it's doing, but after a while, when you've been using Python for a while, you start using advanced ways of coding. Like if you've done any coding at all, you might have got into using for loops, and for loops allow you to iterate through a number of elements, like for instance a range of numbers, for example. But Python has started to, after several iterations of the Python language and a new trend in computer science, we came up with the idea of functional programming. And functional programming compacts several lines of code into one. So that's what this is. And in Python, that functional programming is called a list comprehension. So our second line is a list comprehension, and it looks quite intimidating, but let's go through it element by element to see what it's doing. So we've got property def joints. We've got to send it a reference to self so that goes back to the head of our class. And what this property does, we're going to send back when someone requests this information, we've got to return something. So the thing that gets returned is a list, and we know it's a list because the thing that's returned is within square brackets. So that's the first thing to note. Then all we've got to do is read our command. This is our list comprehension. We read it from left to right. So we're going to iterate. We've got a for loop there. We're going to iterate through a group of elements. So I is just used to step through a list. So I for I in, and here we've got pm.listRelatives. Now, if you remember, we imported pymel.core as one of the first lines of our code. And in pymel.core, you've got a series of commands and methods. And what we're doing, we're going into Pymel, and list relatives is written into Maya, into the actual the programming application interface within Maya. So this command here, list relatives, is used in Maya when we've got an object selected, and we want to find out like all the parents, all the children, all the associated nodes. So what we're going to do, when we go for I in pm.listRelatives, we're going through all the relatives of our root node. So if we look at the arguments inside list relatives, because that is a method call to a different method. So inside list relatives, we tell pymel.listRelatives that we are setting it our root node. So there's our root node, self.root. And we can also give list relatives this second argument, and that's called all descendants. And that tells list relatives to look at every single child, not just the direct children, but all the children underneath. And that's really important for joints, because joints end up being a big tree of data. So pm.listRelatives, what that does is it sends back a list of all the joints. In fact, it sends back a list of lots of other things as well. And that's the problem. So the final part is lets us decide from the list of all the descendants of the root node. We get to specify that we only want to get the joints. So we go if type of I is equal to nt, which is a node type joint. So if the object in this list of relatives is a joint, we want to collect it. So this sort of looks horrible when you first look at it, but after a while you get very used to list comprehensions. So and you can read them quite quickly. So the I for I is the iteration. So just quickly speaking, what we're doing is return a list of the relatives, and the final part says if those relatives are joints. That's essentially what it says if we're going to put that into English. And this is what it sort of works out as. So that, you'll be pleased to know, is probably the most horrible thing I'm going to talk about today, explaining a list comprehension. That's kind of nasty. But if you can sort of get your head around that, if you can't get your head around this and you're more interested, start having a look at some tutorials on for loops, and eventually you'll get to list comprehensions, and you'll find out that they can really help you out. So let's go back, and we've got our bits of code here. So here's our importing of the libraries, and we have that at the top of the script. Here's our definition of our class, and there's our property, which contains our list comprehension, and that list comprehension looks through all the relatives that we feed it, and it returns a list of all the joins. So this is great because now we've got this, we can add more to our character rig script. And here are lots of other things that we can add. It's exactly the same format. So if we want handles, that's some IK handles, we can modify that code slightly to give us a list of IK handles. And we can also query the rig for meshes, pretty much anything we want. All we need to do is specify the node type that we want to find out about. And that will give us our script, when we create an instance of it, that will give us the information back. So this is the line that we'd use once we've got our class set up. We would just have that. We wouldn't need to modify it again. So we have this line here, where so this is the main body of our script. This is outside of the class. And what we need to do is we define our class. We've talked about instances before. So an instance just means that we are taking that model of the class, and we're going to make a copy of it and put our data into it. So it's a version of a class in which we're using the class and we're sort of putting our data in. So what we do, we're going to call this class by creating our variable rig, and we call the character rig. We're going to give it the name of our character model in Maya, and we have to use this command pm.ls, and what that does is it looks for all the objects that have the name Crazy Flower Rig. And then we're in square brackets 0. That just means that the first object it finds that's called Crazy Flower Rig, that produces a node, and that's the node that we've got to send our character rig. So, because if you remember, if you look at the init line of the character rig class, we've got self, but the second argument is root. So this is the root node that we're sending it. We're sending it the Crazy Flower Rig root node. Then the second line, we've got our information, and we've got this print line. Once we've got this print line set up, we can get our code to give us a list of our skin clusters and our handles and our joints. So that's the idea. So let's have a look at how this works in Maya. We'll take this into Maya, and we'll start seeing this in the flesh. Right. So here is our back to our Crazy Flower Rig. So this is my my Maya setup here. I've got my script editor here. And there's very similar tools in 3D Studio Max, and you can use exactly the same principles in Max, but because excuse me, I'm working on an iMac, I'm forced to use Maya, so I'm sorry about that. So in my Maya editor, I'm a technical artist, so I've got a full set of tools here. But I've got a outliner window. Here's our Crazy Flower Rig, and here's our script editor. Right. So here I'm try and sort of blow this up a little bit, because that might make it a bit more easy for people who have to sort of see this stream. So here's our code, and we've got it written out, and So here's our line here. We've got the main body of the code, and we create our class, and here's our calling code at the bottom. In the top part of the window is where we get the information. So let's have a look at this. I'm gonna run this piece of code. So we know that this is the name of our crazy flower rig, and so it's this element here. And when we run this code, we can see here that all the joints get listed. So that's exactly what we want. So here we've created a script that allows us to query our character rig, and it's given us a list of all the joints, and that's great, because say we're working with our rig, and we've decided to give certain properties to our joints, we can collect them really quickly using this script. Or say we wanted to manipulate the mesh, what we would do is when we'd collect our meshes here in our script, we can just call the property, and if I ran that, then we would get all the mesh nodes within our shape, within our rig. And this is what you need to do as a technical animator. You need to be able to control things. So I've got another script that I've been working on as well, and this will give you some ideas of a typical task that I might have to do. And I'm not going to dissect this script on quite the same level, because this is a script that would probably even take me like a couple of days to work through. It's not something I could like cook up in like 10 minutes, but this will just give you an idea of the sort of tasks that we have to do as technical animators. So, and what it is, I've created a script that will allow me to sample a rig, because say we'd have a situation where we have our character rig, and let me just open up the channel box and the outliner. So here's our crazy flower rig, and we have all these inputs on the right hand side, and here's a situation where our rig is all the clusters are set, and all the weights are set, all the blend weights that attaches the mesh to the skeleton. Now, say I had a situation where I needed to get rid of that history. I mean, how would I do it? And the thing is, we don't want to have complicated history on objects when we're exporting them, because it can cause problems, and it's just extra weight that we don't need. So, how would we get rid of that history? Because the important thing we need to do is keep this skin cluster, because that's all our skin weight data. Now, so what I've got is I've got a script here, and this script, it saves our weights. And here, I've got this saved in a library called AD rigging. So my library is where I store all my scripts. So this is my AD rigging collection of scripts, and I've got this function here called sample weights, and this gets our skin cluster, and it puts all the information into a dictionary. So what I'm going to do is I'm going to save all the skin weights from our crazy crazy flower model. So and to do that, I'm going to save them into a JSON file. And JSON's just a way of storing data. It's a JavaScript-based way of storing data. So I've got to create a folder on my desktop. Here's my JSON folder here. If I just open that up, there's nothing in it at the moment. So I've got this JSON directory here. So if I save the weights, I'm going to run this script now, and we just got feedback from our script. Skin weight data saved to, this is our JSON folder that we created. If I go into the JSON folder, we've created this JSON file. So this is exactly the sort of thing that that's super important. So because this now gives us all the information about all the skin weights on the model. And this isn't, and this is the key thing about being a technical animator, because this is not key functionality that you would find in Max or Maya. This is what technical animators do. We add extensions to the software so that animators can go about their jobs. So every single bone is listed, and these are the joints: joint 3, joint 4. And all the vertices are referenced to the bones, and the weights that they have according to which bone they're linked to is put here inside this JSON file. So we don't need to see that anymore, but let's see how we would use that. So what I'm going to do, I'm going to delete history on our model. So to go into my tool caddy, and I delete history. So at the moment we have a situation where we've got our rig and the model is separate. So we have got rid of all that data. That's great. So but now we want to hook this up to the rig again. So what we're going to do is we collect our crazy flower rig and the joint and the mesh. And if we go into rigging, we'll go skin, bind skin. Now, if we scrub through the animation frames, it's bound, but we can see that it's completely janky, the blend weights. But this is luckily what we have got the weights set up in our file, in our JSON file. So all we have to do is use this second part of the script, and I'm just going to activate this. So we define the JSON weights file. So this is a path to the JSON weights file that we created on our desktop. So so that's this path here. And then this is our second script, and it's called apply weights. So if we just go into PyCharm, and here's our apply weight script. And so what that does, it takes a transform, which is our object, and we take the root joint. So we've got the mesh, we've got the root joint, and it takes a JSON weights file. So what we need to do, we've got our apply weights, we send it the mesh. We've got our mesh defined here as the crazy flower mesh. We've got a root joint, and I'm in this situation, I'm referencing the root joint by name. We know it's joint 13. Just verify that, that's joint 13. And the final argument we have to give is JSON weights. So that's our JSON weights file that we created here. So all I'm going to do now is I'm going to run this script. Right. So there we go. Skin weights applied to our rig here. And so we've got like verification that this has worked. So let's just see if we've managed to transfer the weights. And there we go. So this is a really sort of good sort of core introduction to the ideas around the tasks that you might have to do as a technical animator. We don't actually animate as such. That's for the animators to do. That's the character animators. But we're here to support the animators and to give them the chance to sort of do some of the more awkward things. We can see we've got our clean node now. We've got rid of all those extra elements, and so to sum up, as a technical animator, it's very much a role where you've got to get deep down. You've got to get into analyzing like rigs, structures, and we use object-oriented programming to analyze these structures and to develop code to help us to rig, animate, to help us explode buildings, or to like work on explosions, sort of trigger anything that might be related to whatever part of animation that we're going to work on. So I hope that's given you a really good insight into the world of a technical animator, and that's pretty much it for now for technical animation. Right. So I'm really grateful if any of you are still here, because I've got no idea, you might all have like sort of bombed out, or you're sort of you're scrolling through your phone for and like sort of, or you're on the Discord channel. I don't know what you're doing now, but hopefully I could bring you all back. So if you, this might even be the last lecture of the day. I don't know if it's the last lecture of the day. I'm sure your tutor, I can't give you the permission to do this, but you're allowed to open a beer now if you've got a fridge handy. So hopefully you can sit back and you don't have to think quite as much with my and I'm going to talk about virtual reality. Right.
Yeah, that was amazing, Andy. I know definitely the minds of the students are going to be blown for sure. I know we do have some questions that have come through, but we'll save them for the end. Some of them are specific to some general questions as well, but there's some that are specific to what you've just gone through. So we'll save it right till the end. If you guys are happy to wait for your questions to be answered, then.
Yeah, that sounds good, because I'll make sure that we can get enough time to do that.
Sweet.
Yeah. So it is quite heavy in a way, technical animation, and but the thing is about being a technical artist in general is there is the code side of it, but there's also the engine side of it. And one thing that I've been like really enjoying in the last 6 months and well, almost a year now is getting my hands dirty and actually getting into like sort of producing things. And I'm not so constrained by code. And the thing is, there are some technical artists who can make a career from not scripting and just like working with engines. If you want to be a technical artist, I wouldn't recommend not getting into scripting and not understanding that. But you can certainly have a career as a technical artist by just working with engines and components, and maybe just like working with things like blueprints, for instance, in Unreal.
Mm-hmm.
But so this is like virtuality. I don't need to give myself an introduction unless we've got newcomers here. But I'm currently working as a virtual reality developer, and I want to show you a project that I've very recently started, and we can talk about how virtual reality is a sort of quite an exciting field to work in. I first worked on a virtual reality project more than 20 years ago, believe it or not. And I know that sounds absolute nonsense, but what it was, I say worked on. What it actually was that an artist had made a virtual reality exhibition, and I worked in the museum as a curator to help users view this virtual reality space. And it absolutely blew my mind. The idea was that it was based on diving, and the person put their virtual reality headset on, and there was a contraption that went around their chest, and if they breathed in, they would like force air into. The idea was they would force air into their body, and they would sort of float upwards through like a sub-aqua, is that the right word? Sub-aqua space, like a marine underwater space. And if they breathe out, then they would sink down, so they could move around this weird submarine environment. So this was really cool, and it led me on to doing my master's degree. But it wasn't until recently that I started getting into virtual reality development. And well, about a couple of years ago, I got hold of a Gear VR, which I could use with my Galaxy Note. And so the Galaxy Note would fit into the headset. And it was quite hard to get everything to work, because signatures had to be signed, and it was a really tedious process to actually develop anything. And not only that, the Galaxy Note phone got so hot that I felt my eyeballs melting with it about centering in front of my eyes. And then things have changed big time now, and I genuinely believe that the Oculus Quest headset is a complete game changer, because it's quite cheap. You can pick up first generation Oculus Quest refurbished headsets directly from Oculus for $200. Sorry, I'm thinking dollars, so that's about what, 100, maybe it is, you know what, the pound gets screwed, so it's probably £200, but that's really good. It's cheaper than the price of probably even like a PS4. But not only that, the actual development tools are free, and you can create fully professional software, submit it to not the Oculus store, but you can submit it to SideQuest, and you can start your own game development company with just a small amount of hardware. If you wanted to get into publishing games for a PlayStation, it'd be a lot harder, but you're getting a full SDK and the actual hardware to make games with virtual reality. And the audience is growing, and there aren't enough developers compared to the size of the audience. So there are opportunities for new games companies and new experience companies to work in what I think it's a small but a field that does not have enough developers in. And this is one of the reasons that I went into virtual reality. Not because it's an absolutely huge field. The games industry is way huger than the virtual reality field, but simply because there just isn't enough talent there. And if you find a niche that you can specialize in, that other people haven't really sort of gone full swing with, that's a really good sign that it's a career opportunity. And that's why I got into virtual reality development. So this is a cheeky slide which I've managed to sneak in under the radar, and I've tried to make it as safe as possible. There's no swear words, so, and I hope I haven't offended anyone with any of this. I think it's pretty safe. So we're just going to talk about some design considerations and just a general chat about virtual reality development. So there's three key principles with virtual reality, and the first principle is immersion, and we've got presence, and also interaction. This is the key to what virtual reality is all about. And immersion is the ability of a virtual reality system to track you and give you the feeling that you're somewhere else. This is about technology putting you into a place, putting you into a virtual reality space. And presence is subtly different to immersion. And what presence is, it's the emotions of it, the emotions that a user feels of being within a virtual space. And presence is something that's generated by what we do to the user in that space. So we feed them visuals, we feed them audio. It's very much an emotional kind of response to being immersed. And the final part is interaction, because if we're going to make the user feel like they're in that space, then it's a passive experience unless they get the chance to interact with their environment. So those are the three key principles with virtual reality development. And these are principles that we don't really deal with in other areas of technology, like games development. It's not, we have interaction, but, and indeed, in a way, you can feel, when you're playing a game, you can feel that you're not, you forget that you're in the room somehow, but it's very different. It's a, you'll understand if you've used a virtual reality headset or an HMD, that you actually feel genuinely displaced. And so presence is the key out of all these three, and these three words, these three concepts, and presence is what we try to achieve. And we can talk some about the platforms that we have. Like at the moment, there are loads of options. We've already talked about the Oculus Quest. So the Quest 2 came out possibly, well, just under a year ago. And it was more like sort of 6 months ago, more likely. And the Quest, it's $400. Again, I'm guessing that means £400. And so the Quest 2 it's a really powerful piece of kit. There are rumors and rumblings that there is a new Apple headset coming out soon. And there are also other options as well, like the PlayStation VR system, the HTC Vive, the Valve Index. There are loads of options. And what that means is that we've got to develop software. We've got to make a choice about what we're going to put out. So it's a key design consideration to work out what platform you're going for. So currently I'm developing for Oculus Quest, but if I've got to make sure that I use systems and technology that might allow, say, an HTC Vive user to use my technology. Like in Unity, we've got Oculus make a special development kit that gives you all the tools you need to make Oculus virtual reality experiences. But the problem is, if you use the Oculus integration, you won't be able to make games and software that an HTC Vive user would use. So that's why we've got to use a more open, more agnostic kit like the XR interaction toolkit, which was developed by Unity. So all these all have like sort of ramifications on what we choose to do. So in terms of what engines, I mean, I'm a big fan of Unity. Unity is very popular in virtual reality, but also Unreal Engine. Unreal has got plenty of virtual reality support. I was just having a word with Jin, and Jin was telling me about a new SDK that's or a set of add-ons to Unreal, which completely give you all the tools and the presets that you need to make virtual reality software. So we've got a lot of that in that Unity as well. Although you often have to sort of do a lot of the hard coding yourself in Unity, but that's absolutely fine. So there are other engines as well. There's Amazon got one called like Lumberyard, and the old school engines like CryEngine, and there's even like specific engines like Apertus VR is like one example of that. But there are sort of lots of options, but you're going to get more resources generally if you go for like Unity or Unreal. So there would be my choices. So when I talk about applications, we can sort of consider what we might actually be developing. And there are loads of applications for virtual reality. Obviously, there are games, but we can do, one of the projects I worked at Dublin University was this was about 8 years ago. No, it's about 12 years ago. I worked at a side project at Dublin University, and we did virtual reality surgical simulation. And that was kind of like nasty, to be honest, because we were teaching surgeons how to, there was a real apparatus where they put their hands inside like a cowled apparatus. And they had sort of plastic sticks that were but when I looked at the screen, these were scalpels that they were using on a patient. And we were like cutting up their guts inside them. And so we had to create this like model that had loads of veins and sort of throbbing things and things that bled. And that was like really cool. So you can do some really, really powerful things to within medicine. We've got applications within defense training, we've got simulation. And certainly there are Ministry of Defense jobs. There are jobs in the military. If you feel so evil that you have to help those kind of organizations, that's your career choice. But there are certainly some great opportunities there. And there are lots of other areas as well, like architecture, like visualization. If you as a VR specialist, well, certainly a company like Foster's, like Norman Foster's in London, like a huge architecture company, they'll have a full VR team to help clients check out their designs or give them options about what clients might want to do with their spaces. And then there's other things we can do with virtual reality, like we create therapy applications to soothe people. I heard that an app was developed to help children get around the idea of getting injections by giving them an animation of and it was something like a bee that lands on their arm, and when the bee lands on their arm, it like sort of takes them. Actually, that would be kind of traumatic. So it probably wasn't a bee, but it was probably something nicer than that. But that's sort of a more therapeutic idea. And also we've got direct entertainment. We can tell narratives. If you've got an Oculus Quest headset, there are some great immersive experiences. I can't remember the name of it. There is one brought out by the Oculus team that sort of puts you in the middle of the forest, and you encounter a huge robot hand, and a narrative develops all the way around you. And also there's the Anne Frank experience on the Oculus store at the moment, and that's like sort of an educational piece of software that gives you an insight into what it would have been like to experience the spaces that Anne Frank had to experience. And so it's like a virtual museum. And we've got 360-degree video as well. So if you're an endurance sports athlete, you can get a 360-degree pano camera, stick it to the top of your helmet, and you can sort of throw people into your experience by showing them not necessarily virtual environments, but real environments, and just give them the 360-degree experience. So there's loads of applications. So, and the final thing we've got to talk about with virtual reality development is comfort. This is so important, and because when we make virtual reality applications, it's the one thing that we really struggle with, because it's so easy to throw the user into a situation where they just feel disoriented. And the problem is, virtual reality, if we move our user around, then their eyes are getting different signals than their ears are getting. So our sense of balance, and we get a mismatch between our sense of balance and our vision, and that creates all sorts of problems. So that's creates some like motion sickness, like nausea. And so our design considerations for that is that we've got to create experiences where we ground our user. We've got to be careful about using applications that travel the user around too quickly, make sudden turns, and latency is really important, because latency would be where if you turned your head and the application takes too long to catch up, that's the sort of thing that can trigger queasiness. So the ramifications of that are we've got to make really optimized software, so that if everything's as low poly as it can be while still looking good, then we can have a fast experience. So we've got to really be mindful of a lot of these ideas as well. And like Google, they developed a concept called tunneling as well, because when we actually move through a virtual space, it can be a little bit disorientating if we just like move to places quickly. So tunneling is the idea of just reducing the detail in the peripheral vision while we move, because then the user gets something to focus on rather than sort of starting to look at things that just don't matter. And I've certainly found that with 3D experiences. I remember watching like Avatar, and one of the problems with Avatar is that there's too much going on in the sort of peripheral space. I sort of find that even though the action was like happening right in the middle of the screen, and the camera is trying to focus me there, but I kept keeping my eye focused on a piece of detritus that was floating just towards the left of me, and it was like really distracting. And you really got to understand that the action happens like right in the middle, because I think 3D films like learned that it can be like a little bit discomforting if you keep away from that central zone. So I'm going to start talking about my project now. So one of the projects that I worked on was the idea of creating like a boundary space. So what we want to do is it's the idea of we create a space that matches a real world space. And that's the idea of this project. So rather than an imaginary space, we're actually like taking a space like the first time I did this project, I did it with my own house, and I had to measure it out, and then I got a representation of this of my own home, and got it into a virtual reality. So when we create this what I called a boundary space, we're creating essentially that visual reference to create presence. And when the other thing about the boundary space is that when we've got tables and walls like mapped out, this is like really good, because we can create a virtual reality experience where we can literally walk around our own environment, and when we touch walls, we can feel them. When we touch tables, we can feel those as well, and that really helps to give us presence. It really helps us to believe that we're in the space. And once we've got this all set up, of course, we don't just when we've got a boundary space, we've got all the everything just needs to be blocked out in terms of where the floors are, where the walls are. But this gives us a template, and then once we've got this template, what we can do is we can turn our boundary space, for example, into a dungeon or a spacecraft or Yoda's hut or anything that we want to. And that's like a really powerful idea. And in a way, I thought I was kind of smart, like coming up with this idea, but it turns out that other people have done this as well. So this is a thing. But as is with anything within technology, it's such an experimental area, and lots of people have got ideas, and sometimes sort of like minds think alike. So this is a voxel guy. He's created a boundary space, and he's got a series of skins, And he's made a realist representation of his flat. He knows where all the tables are, and he can touch them. He's assuming that he hasn't moved his furniture. He's not going to like clatter into anything. But importantly, he can like reskin his space. But he's defined the boundary spaces, and he knows where his sofa is. But that sofa doesn't have to be a sofa, because he can like reskin the whole space and do whatever he wants with it. So this is the idea. So here we go. So he's created like a matrix style space. So and there we go. Bridge of the Starship Enterprise, or well, not really. Bridge of like a really small space capsule on a weird world, whatever. But this is the idea. This is the project that we're gonna like work towards. And let's talk about what we need to do to actually create a boundary space. And the first step is doing a survey. I first did a survey when I did my architecture degree, and I did an architecture degree before I did my master's degree. And architecture would have us the first thing we'd do is go to a site and measure it up, take photos. So that's exactly the process that we need to go through with our boundary space. And we need to be quite accurate. There are software solutions to using augmented reality tools that will allow us to actually work out a 3D space using like modern camera, like the iPhone 12 Pro Max. But if you don't have access to something like that, and possibly even the expensive software that you need, then we need to go old school, and to create a boundary space, we just need to measure it, like sort of using just tape measures, whatnot, traditional tools. So we need to get all the major surfaces, the floors, ceilings, any of the major boundaries. And it's best to have an enclosed space as well. We don't really want to be dealing with a space where there's an open door. So, but it's good to put where openings are, because if we really wanted to, we show where the openings are. We can, if there are openings in the wall, we can move through them using some kind of port system. But also openings in the floor are really exciting. If you've got a boundary space and there's a big hole that drops down into your cellar, you need to put that into your model, because the user needs to be aware that there is some kind of a danger. And of course, the other type of opening is ceiling openings, because you can have really interesting light coming down in your boundary model. And that's something you might want if you're going to do like a sort of more photorealistic kind of thing. You want to put all that into your template. So those spatial dangers and obstacles, as I was saying, you don't, if you've got like an open fire in the room, the user really needs to know that they're not going to like burn their face off while they're like stumbling around the room in their VR gear. So that's super important. And I put down like fixed furniture, because it's good to sort of, when we build a main boundary space, there are things that are just not going to move. But because of course the non-fixed furniture, they're going to be separate. They're going to be props that we're going to model separately, and they're not. We don't know if they're going to be there when the user uses our software, if they're using the software that we create it's sort of as a literal sort of boundary space model. So now we'll just go into the tools that we need. This is probably the most important tool that I could recommend for doing this kind of work, and it's a laser pointer. This takes all the pain out of measuring. You definitely need the notepad, and we have to create a lot of drawings, get all the measurements. It's like, as I say, it's all the floors, all the ceilings. We have to draw out the space, and the ceiling heights can be quite important. But yeah, we have to sort of I mean, we don't need to do things like get like soffits and like rims and, you know, subtle changes in material or anything like that, because we're just creating a collision model. That's essentially what a boundary space is. It's a visual collision model. And we need to take loads of pictures, loads of reference, because once you've got away from your survey site, you've probably made mistakes, and there's things in your diagram that you won't be able to figure out from just what you've like written down in your notepad. So we need to take lots of photographs, and you really do need an old school tape measure as well. There are just some things that are quicker to just measure quickly, you'll find. And I use my spirit level, because what you find sometimes when you come to measuring things that are in awkward places or things that are offset, you can use spirit level to make sure that you're sort of using your laser pointer from a place that's parallel to the place that you're measuring from. And like finally, the other tool that you need to get to the more awkward measurements is you can't go wrong with a step ladder. You really need that. And once you've done that, you'll have a set of notes. So here are the notes that I took on my kitchen, and you can see the plans there, and I've got the wall thicknesses, and I've just plotted out where the rough areas of the sinks are, where the cupboards are. I've referenced the cupboards by number, and I've put their floor heights. And also, when our kitchen like just leads to a stair area, so I had to put some information there about the stairs. And in that case, it made more sense to actually draw it in elevation rather than in plan. So and it can take a long time to do like a space. So it took me about 2 days to do the main area of our house. So it is quite like a big job, but I could probably have done it a little bit more quickly, because I ended up doing a second project, and I'll tell you about that quite soon. So the second boundary space model I worked on, I worked with a friend of mine called Matt, who owns a bar in Oakland, California, called Eli's. Eli's is shut down at the moment, and that's one of the reasons that that Matt's really interested in getting his bar. And so Eli's is a dive bar, so it's like it used to be like a blues bar, and now it had turned into like sort of a bit of a punk and metal bar. But he wants to use his space to show virtual reality concerts, and he's been doing like live streams, and he wants to bring in augmented reality from when the virus starts to phase off and people are allowed to come back into the venue. He really wants to use it as a technological playground. So I've been working with Matt to help him create like a boundary space model, so that we can build it up and eventually create a virtual version of Eli's. So here's the model of Eli's that I put together, and we've got like sort of stage area, bar area. This is the main room, and and if there are a bunch of tips I can give you about what I found that we had to do in making a model. So this is my bunch of tips. We need to work in meters. And in fact, when I was working with Matt, he was like measuring things in inches, and that's absolutely fine. Like Americans don't get like metrics, so that's just something we've got to work around. So, but I ended up actually creating a tool in Maya that automatically converted to meters. And the reason we're working meters is because Unity works in meters. So always remember that, get your measurements in meters, and or at least find a quick way to convert to meters. And then you've got consistent units. And when you're working in Maya as well, make sure that you set up your system unit in meters. I say generally use quads. I don't like to divide triangles unless I have to. And if I have like a really sort of awkward like quadrilateral shape and that's unbalanced, I will turn it into a triangle. But it's there used to be a trend for triangulating absolutely everything. But if something is if something can be sort of fairly balanced as a quad, keep it in quads, but generally avoid quads. And I say avoid end guns. But if there's one situation that I would consider an end gun, it's for a shape that is quite circular, like an octagon or a dodecahedron or something like that. But for anything that's kind of like jagged shaped like that, you want to turn it into quads and what you can't triangulate. And I say avoid unnecessary subdivisions, because there are subdivisions that are worth doing. If you're going to like sort of divide your space up into zones, those are kind of good subdivisions. Eli's was quite big, and I didn't want to do it all as one big model because it's really hard to sort of get inside if I can't, and it's a lot easier to organize if I divide it into zones. So the only subdivisions you should do are ones that make sense or give you like solid reference lines so you can like line things up. But we don't want to be adding extra geometry in there, because like ultimately it's a visual guide. It's not a final model, and ultimately we may end up using it as a collision model, but we want to avoid extra detail. Like in Maya, I found that I was using locators quite a lot, and using locators is really useful, because with locators we can put the locators directly on reference points in space, and we can use the transform type-ins to give us accurate measurements. And then, so that's what we use to transfer all the information that we got from our notes onto the actual model. So the transform type-ins give us the accuracy. I mean, and that's true architectural accuracy. The model will come out with would like, you know, suffice to be a CAD model virtually. We really are sort of going for accuracy. I mean, it's not going to be perfect. It may be centimeters out. It may even be as much as half a meter out, but we should at least try to get things to work. And definitely one of the things I found was when we're doing curves, because you can see that there are a couple of arches on like one of the walls on the Eli's model, and there's a curved area which is like a desk, and that's like the sound booth, and both of those were created like using splines. When we create splines, we can create parametric polygonal geometry, and that's really nice because we can save those splines in our scene. And if we want to change the shape of the spline, it's really quick to do so. So that's quite nice. And also we can with splines we can do like offsets, and we can create loft objects. So it's really nice about it. Have like reference splines. And yeah, I like backface culling is definitely a friend when you're working with these kind of models, because I worked in a situation where I didn't separate the ceilings from the main objects. I wanted to make enclosed units, because if I had separate ceilings, I'd constantly be getting mismatches between the walls and the ceilings. So because I was like modeling the ceilings into these interior spaces, like backface culling was sort of quite important. So we break up our space into workable zones, and as we say, just areas that make sense, so that like in my model, for instance, we've got the bar, we've got the mosh pit, we've got the stage, we've got a pool area. So so these are the sort of the zones that we're working with. Oh, this one's like super important. Save all the time. As soon as you've done anything of note, it might have only been like 5 minutes or 10 minutes since you saved. Save. I do not rely on like autosave. Make sure you do this. And And if you can, you may not be able to do this if you're working on campus in college, but saving on cloud or a Dropbox is really useful as well. There are some forms of like backing up your work that it's done automatically through things like Dropbox, but saving iterations is the best way that you can have of making sure that you're not going to lose work. And like finally, we don't want lots and lots of history on our objects. They're not gonna help with the export process, and ultimately we've got to bake things down. We've got to make them flat. So that might be a technical artist thing, but I like to work with that really clean geometry. So once we've created our model, the next stage is to get it into the Oculus Quest. And so there are a variety of steps that we've got to take. So we've got to install Unity, and there are some other tools as well that we've got to install. Like I'm working on a Mac, so I install Xcode, Apple's Xcode, which is an integrated development environment, an IDE. And we've got to also install the Android SDK specifically for Oculus Quest. And once we've got those set up, we've got something. We can connect our Oculus Quest headset to our computer, and there is a set of tools called the Android Debug Bridge (ADB), which we can use to connect with the Oculus Quest, and then we've got our development kit set up. So here's what we do inside of Unity. The first step is within Unity is we've got to set our platform to Android. So Oculus Quest is based on Android, and we've got to install the XR packages. So in the project settings, this is, if I haven't said already, this is Unity. But the XR interaction toolkit is what we talked about before. So it's a platform agnostic virtual reality development kit. So if you use Oculus integration, you'll only be able to develop for Oculus Quest or Oculus Rift S. But I'm a really big fan of the XR interaction toolkit, which allows us to build for HTC Vive, whatever we want. So we've got to add the XR plugin management, and in this example, we have different plugins we can add. We can add AR Core for presumably some kind of like Apple supported like hardware, and we sort of configure our options. So we have to then go into Maya, and we've got our model. We've created our model, and we've got to make sure that the FBX exporter is loaded in the Maya plugin manager. And we then in the options in Maya, we get the chance to export to Unity. That's something that came in a couple of years ago, and all we need to do is point to the project that we create in Unity, and then we can export directly into the project. So we get our FBX model, and we can drag it straight into our scene. So with the export that we've exported into our Unity folder. So here's our scene, and I've taken the Eli's model, and I've just dragged it into the hierarchy bar, and that pops up in the center of our scene. So the next thing we do is we've got to add an XR rig, and we've got to add the lights as well. We've got so we'll have the lights and the XR rig. Right, this has just gone back. So right, and lots of clicks there. So set platform to Android. Quick recounter, aren't you lucky? We extort the XR packages, FBX from Maya. we create our new scene, XR rig, and we're back in the room. So here's the next step. We've got our lights added, we've got our XR rig added, and you can see in the scene I've got the scene lit, and the XR rig. What the XR rig is, this comes with the XR interaction toolkit, and this is the representation of our HMD, our head-mounted display, and it's the XR rig has this camera offset node, and as a child of that, we also have the two Oculus controllers, so they're part of the rig, and then we need to connect to the Oculus Quest. So sometimes you've got to give the Oculus Quest a bit of a kick with, even if it's connected by USB, sometimes you need to bring up the Android debug tools, which we can do in like a shell window. So on Windows, that would be MS-DOS, or on Mac, I'd use Terminal. But there's the really simple commands to just make sure that Oculus is connected. And like finally, we can build it and run our project. We've got it all set up. We've got the XR rig. We've got a light. We've got a model. We've got the connection, so we can build. So like, I'm going to show you our projects that Matt and I have been working on so far. So this is Eli's. It's called Eli's Mile High Club, and it's a really old blues club that's been in Oakland for probably about 80 years. And like Matt bought it up when it was in a doldrum period, and he sort of converted it into like a modern sort of punk rock dive bar. But at the moment, you can see the screens on the left-hand side, and he's like using it as a virtual reality performance studio. So bands are coming in, they're filming them using pano cameras, and they're broadcasting them on the Eli's channel. So that's really interesting. So they're doing like the pano side of the work, and then I'm doing the virtual space side of the work. And it's a really colourful space to have a go at. I am not looking forward to modeling all those glasses. And all the shaders. Seriously, that is going to be a headache. But that's absolutely fine, because all we're doing is creating a collision space. And once we've got the collision space, we can use that to actually create a high-def model, if that's the direction that we want to go to. But I'm hoping to convince Matt that we have a go at making kind of like a sort of a much more kind of stylized affair, because getting that much information and like all those glasses into a virtual reality model where we've got to be really careful about how many polygons we put in, it's going to be hard. So we just need to be strategic. So I think one of the best things about Eli's Mile High Club is that what we can do with the lighting. So I'm really looking forward to developing some neon shaders and get the light working, but get the light interactive as well. The sound desk at the back of the room is going to be like a bit of a point of fun, and you're going to be able to like sort of get the disco lights working, change the light colors, and that's going to be a whole load of fun. So here's so I got the model all set up. I built and ran it, and late last night I just took a quick I got them. This is a render of the space, and I made a quick movie of what our project sort of looks like on the Oculus Quest. So I've only got very sort of basic lighting in at the moment, but this is the main space of the bar, and what I've got here, I've got a teleportation system. Because when you've got a collision space, you can, as long as you start in the right reference point, you can physically walk around the space and you're fine. But because I'm sitting in my like really humble man shed here, I've got to I can't walk around Eli's while I'm developing, or I'll start walking into all my synthesizers and the things I've got in my studio. So I use this teleportation method to walk around. And this is like sort of a really nice way to sort of get around a space. And the thing is, I can never capture what it actually feels like to be in a virtual reality experience. Oh, here we go. That was an example of a rigid bodies. So I've got these chairs actually respond. So that's how we can make games. But yeah, seeing this flat on screen is nothing compared to actually being in a virtual space. It is completely different, and I can't. It's like one of the ironies in that being able to present to you via a Zoom is both exciting, but it's also, if I was in the same room with you, I would be able to show some of you actual virtual reality experiences. All I can say is get hold of a Quest or borrow one and actually it's like dive in. But if you get the opportunity to develop your own spaces, it's so satisfying to stand in a 3D model that you've made and actually feel like you're in it. It's such a big buzz. So that's the end of the presentation, and I can quickly show you what it's like on my real Rift. This will take a couple of minutes, so this is going to be a little bit experimental. So, but I'll get back in Maya. I will just quickly show you my Eli's model. So here it is. So here's my the latest version of my Eli's model, and I've got the main spaces here. So that's the stage area. I've got that area there is the pool room. Then this is the then here I've got the bar. And to get this all working, as I say, I took a load of measurements. There are hundreds of photos, and I constantly need to go back and check the photos just to make sure that I can get all the details. And as part of the collision model, I have started to put in some of the details. But this, for example, I modeled this as a prop, and developed this just to give a demonstration of how the rigid bodies can work. So this is great, sort of reusable prop. Just design it once, but I can put it in as many times in our Unity model as we need to. So let's go into Unity, and here's our space in Unity. We've got these teleportation points, and the teleportation points are assets that we can get directly from Oculus. So Oculus have made demo scenes with virtual reality assets. So we just need to add those packages, and that gives us these teleportation points. And the lights are we can choose the colors and directions of these lights. So I'm just using basic point lights. Now, eventually, if we work out what we want to do this model, we'll create an interesting simulation, and we'll get some real-time baking. But now I'm going to take our project. I've got it connected via my wire to my computer, and if I go into build and run, so this is me. I've clicked build and run on the screen. It's looking for a compatible device. Has it found my device? It's found my device. This is really good. So just going through building the shaders, and I should be able to share what I'm doing when we get this up and running. Right. It looks like we're successful. Trying everything live. Yep, that's really good. So this has worked. So you can't see any of this, so I'm sorry about that. But we've help is at hand, because I can show you what I can see through my two eye holes. Right. So here we go. So this red cage around me is my boundary space. That's Oculus telling me that I can't fling my arms around or I'll destroy my iMac and all my synthesizers and whatnot. So that's really handy. And on my left hand, I've set up, this is a sphere. It's set up as a rigid body. So that gives me some physics to play with. And on my right hand, I've got this interactor. This is an interactor, and this allows me to interact with the teleport units, and then I can sort of go to them as I choose. And so one more thing to mention, there's another form of interaction we've got is on my thumbstick on my Oculus hand controller. I can physically turn around as well. So that's called a snap controller. So let's have a look. I don't want to move too quickly because I don't think I'm going to make you sick, but I might make me sick if I do that. So I can jump over here and have a look out the window, or well, we're having an idea of what we can do in our space, and like one idea is we can be a virtual barman, and we can get a game going where we have customers and we've got to like serve them drinks on the bar. And so this is outside the bar. We've got our pool area over here, and there used to be a pool table here. We're thinking of introducing like a virtual pool game. So and obviously we've got this is the mosh pit. And of course, like up on the stage, we can check out what we want to do on the stage. But the sort of final thing we can talk about is, so here's our we've got our sphere set up as a rigid body, and we can actually like interact with things in the space. So this gives us the presence that we're sort of talking about. So that's me trying to like knock over that chair. No, the physics on that is absolutely terrible. Am I going to knock it over? Yes, it's gone. Right, there we go. So this is probably the worst game ever. This is the knock the chairs over in a room that's got no textures in game, but that's something that we can sort of put together quite quickly as an experience, and gives us something to sort of bounce with. So that's my introduction to creating a boundary space, and we can take some questions.
Amazing. I just want to start off by just thanking you, Andy. That was 2 intense hours of just beautiful technology and techniques. So thank you very much. And I'm sure all of our audience here are really, really appreciative. Yep, we can see the claps coming through. Claps with the mental pain. And intense. Applause.avi. Yeah, thanks again, Andy. We've definitely got a number of questions that have come through, and I think it would be great to start it off just by saying one of the really exciting parts about what our students have been working on this year, especially our third years, is recreating real-life environments in Unreal. And in doing so, a lot of the process and the workflow that you've discussed, although it wasn't for VR, it was for a Unreal Showreel project of a real-life environment that's been gamified and reimagined. So to make that into a VR project is a couple of clicks away from being able to enjoy those real-life environments in VR. So that's lovely, and I think it's tied together quite beautifully. So just jumping straight into the questions, guys. Going right the way back from the start, when you started introducing yourself and things like that. So when you were working for Rockstar, what issues did you and the team struggle with when developing some of the games you had worked on?
Problems was what we did as technical artists. So I can talk about what I did as an environment artist, and like one of the things that we had was just like dealing with environment mesh. I was an environment technical artist, so we just had to make sure that everything was optimized. So the main problem is that artists don't optimize things. They make things pretty, but they don't make them optimal. So the problems were giving them tools so that they could make things optimized. So I could, for instance, give them a tool so they could find out why there were 500,000 too many polygons in their scene, and they find there's an absolutely tiny asset that they scaled down and forgot about, and they can locate those things quickly. Or we also made tools to sort of give them find out if there were erroneous parts of mesh. Say that they had irrelevant triangles that were infinitesimally small, or like triangles that were really, really, really sharp, that we gave them tools to sort of help them get rid of that. And the other big challenge was I worked on a Red Dead Redemption 2, and I had to all the map was divided into 512 by 512 meter grids. And the problems I had there was that if an artist worked on one side, what happens to the other side? So there was a problem there, because you get a rip, and it's not just a geometry rip, it's a texture rip, it's a normal rip, it's a lighting rip, it's a material rip. So that's another of the sort of problems that we had to face. So it's about making tools to make sure that sort of two pieces of mesh can like completely zip together after like work has been done. So it's just challenge after challenge. And I'm sure if I talk to one of the technical animators, they'll have a similar long list of problems that they had to work with as well.
Awesome. And you've also answered the follow-up question was, what projects at Rockstar did you work on? But outside of RDR2, what are the other projects that you worked on at Rockstar?
Yeah, I first worked on Max Payne 3, and I did some of the environment on Max Payne 3 actually, because one of the artists resigned. So I spent about 6 months like sort of covering some of the things that he was like working. But then I sort of got back onto the tech art, and I was a technical artist all the way through Grand Theft Auto 5, and then it was pretty much onto RDR2.
Nice.
And they would when I only left about 3 years ago, but even 3 years ago they were working on another project. But it's all super hush hush. But the thing is, you can probably guess what it is all I can say.
Oh, that's the closest you're going to get to a spoiler, guys.
Right.
Amazing.
I would love them to make Canis Canem Edit 2, Bully 2, but I just don't think it's ever going to happen.
Yeah.
And there was a kind of like a really nasty Manhunter game as well that I'd really like to see, but yeah.
Yeah. Who knows, right? Next question, and coming slightly away from just from Rockstar. If I already know C#, would you recommend I also learn C++ or any other coding language?
Well, the thing is, when you sort of learn how to code, it's a base skill, and the principles pretty much hold fast if you understand object-oriented programming. And what I would say is it's probably not a great idea to jump into C++ unless you know that you're going to concentrate on being a full-time programmer. And that's because C# handles a lot of the memory allocation automatically, as does Python. That's why technical artists like it. But C++ goes down a lot deeper. And when you create objects and like manipulate data, you have to start managing the memory allocations. And so if you stop using, see, you create an array. If you stop using that array, if you just like leave it there, then it just hangs in the computer's memory, and you'll eventually end up crashing your application. So in C++, you've got to deallocate memory when you no longer need it. It's a much more manual, lengthy process. It creates much quicker code. Well, that's for software engineers. Definitely learn C++ if you want to be a software engineer. But if you just want to write code to help you out as a technical artist, technical animator, or even as a regular artist or animator or whatever it is, I would generally try to keep away from C++.
Brilliant. I think that's a good message. I think just off the back of that, Andy, what do you feel about Python in that case? So do you think it would be a worthwhile investment picking up Python? And the actual question here is, would Python be useful if I don't want to be a technical animator?
Yeah, well, Python is really interesting, really flexible. It's platform agnostic because there are certain situations where, for instance, C# it becomes hard to use. I can't easily develop visual applications on a Mac, for example, with C#. I mean, okay, you might say, well, I'll always use PC, because if you work at certain companies, like if you got a chance to work at Google, they might very well put you on a team and give you a Mac. But ultimately, the languages and the grammar, the understanding, the core principles, it doesn't actually matter what language you learn them in, because they're all transferable ideas. If you understand object orientation and the principles of object orientation, then they transfer from language to language. Because I found, for example, that when I worked at Facebook, they wanted me to use JavaScript. And I could take everything that I knew in Python and just transfer it to JavaScript. The only thing new I had to learn was syntax. And what they say about Python is never the perfect tool for the job, but it's the second best at everything. Mm-hmm. It's the second best language possibly for Maya, because if it's the best language, you probably use C++. But it's the second best for so many areas, and it's so simple, and it sort of hides a lot of the complicated side of programming. It's a really good language to sort of do problem solving with, and you'll find that it's taken up to do kind of abstract problem solving. And I find it like super flexible, and and so many software applications support it. I mean, I would, for someone who wants to learn programming, I would always recommend Python. And if you want to get deeper, you can do that at a later stage.
Yeah, that's great. I think you've heard it, guys. If you're going to want to get into any kind of code, use the second best language, which is Python. And I'm sure it will be transferable across a lot of the applications you'll make use of. A bit of a long question, Andy. And we're coming quite close to the end. In fact, we've gone past the end, but we'll just answer a few more questions before we wrap up. With many areas of games development becoming easier with new tools like motion capture and Epic's new Make Human to create realistic characters that are pre-rigged, do you think that this is going to make it harder to find a job in the industry?
Yeah, the MetaHuman system looks like really interesting, but I don't think it's advances in technology that is the thing that's going to make it harder to find work in the games industry. Because I mean, what happens? The next generation of hardware develops even more sophisticated tools to help the development teams to use those tools. So as the technology advances, the tools have to advance. Sure. But I think it is harder to get into the games industry year by year, simply because the actual sort of the skills source or the skills pool is getting more and more saturated every year. Mm-hmm. And there's a point at which you could argue it's reached capacity. I don't think there are necessarily few. I think there are more people working in the games industry every year, but there's for every say 1,000 more people that the games industry needs, there may be like sort of 50,000 more people in the pool that are looking for those jobs. It is getting harder, but not because technology is advancing, just because it's getting saturated with talent.
Well, that's really a really clean answer, I think. I think with that in mind, Andy, as maybe one of our closing comments to the students, if there was a piece of advice on a skill that the students should develop to look into emerging technologies or to look into the existing technologies, what do you think that the students should push towards in improving their employment prospects within this now becoming saturated, more saturated games industry?
Yeah, I think that comes down to the old adage, where there's muck, there's breast. And if you sort of consider the most obvious areas of games development that look really exciting, it's probably being something like an anime character artist. And if you sort of think, oh, I really like anime, I'm really inspired by a certain like forms of anime art style, I'm going to make myself an anime character artist. That's what I want to do for a living. That's great, but you put yourself in a queue behind hundreds of thousands of people maybe, whereas you want to put yourself in a short queue. So the best thing you can do is find a specialization which might take some really hard knowledge to actually get your head around. Not something you can learn easily, but not something anyone can learn easily. And there is in fact an accountant from the 1970s, 1960s called Michael Slater, and he invented something called the Zulu principle. And he invented the Zulu principle based on the idea that he was having a conversation with his wife at breakfast one morning, and he started talking to his wife, who'd been reading a book on ancient Zulu tradition, and he realized that his wife had read this quite obscure tome, but from the knowledge that she already had, she was probably one of the most expertised people in the world about Zulus, simply because she'd like sort of gone for this precise knowledge. Now, if you find areas in technology that are hard to learn, specifically hard to learn, and you work out how to do them, you put yourself in a very unique place. And there are areas to look for at the moment. Certainly, I think that virtual reality is quite tough, because what I find is I don't get very far until I get to a point where I ask a question like, how do I do this? And the answer just isn't there. And that's when it gets hard, because I need to like sort of dig in and work out how to do it for myself. Mm-hmm. That's when I start putting myself into a position where people ask me, how do I do this? And it's like, I know the answer, but you're gonna have to employ me to find out. That's what I'm trying to do.
Yeah. And
there are lots of zones of interesting. I mean, for instance, in technology in general, for instance, digital tokenizing is like one of the new exciting fad areas. It's incredibly complex, and it's new. And the CEO of Twitter just sold his first tweet as a digital token, and it's millions of dollars for it. Now, the technology behind that is something that maybe like a really small handful of people in the world know about. If you like spent 6 months researching that, you could probably get a job at Amazon, Google, and you'll be earning $250,000, but within 8 months. But it's not easy, but that's why these roles are so well paid, and certainly, but on a lower level, if you find any particular discipline that interests you, because these areas are like sort of hard to learn, but you've got to be interested in it. You can't just learn something dry, because if you really want to make a lot of money, you can study something like deep algorithms in fintech and start working for a merchant bank. But that's tough, and it's like really dry. But definitely look for niches, look for things that are really hard to do, and work out the steps to do them, because the answers might not be there.
I remember you describing them in a previous lecture, I think it was 2 years ago, as those unicorn roles. And they're very much sought for. And in some instances, those roles are yet to be invented. And in an industry where we have so much new technology always around the corner, it's with the new technology come new roles as well. So I think placing yourself and developing those skills in that industry is so important, isn't it?
Definitely.
100%. Andy, thank you so much. It has been an absolute pleasure as always, and your extensive knowledge is always astounding and always exciting to be in and around. Guys, I'm sure you can extend your gratitude via a virtual applause once again. blow up that chat and pass on your thanks to Andy. Wonderful.
Okay. Thanks a lot, everyone. Great.
Nice one, Andy.